DC motor. So what that means is that there is a tiny, just right on the end there. So those terminals are what are going to be soldering the wires onto. And the other end of the motor, what's mostly encased in the yellow plastic there, is a gearbox. So it's a 120:1 ratio gearbox, meaning that the electric motor will be whizzing around very, very fast. You'll hear it running, buzzing quite fast. But the shaft of the motor, which is this pink plastic part here at the end, that is going to be turning relatively slowly. So we're trading off motor speed for torque, right? It'll go 120 times slower than the actual motor, the rotor of the motor inside the casing, but the torque will be much higher. So we're trading off speed for torque. Available in each of the workshops downstairs where you're going to be working. Now there's a couple of important things to know about this. We're going to be using this to melt the solder, and the solder that we're talking about is some kind of an alloy of, I think this is mainly tin and silver. So older solder used to contain lead, but they don't. They're not allowed to put lead in it anymore. So, so this solder here, you can see it's a very sort of a thin strip of metal, and it has a very low melting point, like around, I'm not sure, any idea? 230 Celsius maybe. Okay, so it's quite a low melting point, and we're going to use this to create electrical connections between different components. Now the breadboard means we don't have to do this for most of the connections in the circuit, but one place you will have to do it is for the motors. You're going to have to put wires onto those two little tiny metal terminals on your motor. So I'm going to take a bit of this solder, and we're going to use the iron to melt it, but there's a few tricks here which will make your solder connections much more reliable and robust. Can I just get a show of hands of anyone who has soldered before at all? Okay, that's good, right? That's probably about 80% of you. Now, just a warning, even if you think you know how to do it, I would ask you to pay very close attention, because there may be some ways that I suggest doing it which differ than what you've done before, and that is often the case. Couple of safety things to mention. First of all, before I do anything with the iron or melt any solder, I need to have the safety glasses on. So that's the first thing. Let's put down these ones here. Yeah, they're a bit clearer. Okay, so these are my safety glasses. If you wear glasses yourself, that's okay, provided that they cover your complete eye area safely. If not, you can normally put these on over glasses if you've got a small pair of glasses. I'm going to be soldering on wire just because we're limited in the availability of wire here. I'm using black wire. That is not a color that I would recommend using normally, because we'll always be using black for 0 volts everywhere in the circuit. And the wires to your motor might sometimes be at 0 volts, but they won't always be. So this is not actually a good choice of color of wire, but I'm just going to have to go with it for now. The length of wire that I'm going to connect onto each terminal of the motor, you want to be sure you don't put on too short a wire, because you might want to position the motors some distance away from the circuit. So I'm putting on, this is probably about 20 centimeters of wire onto each terminal of the motor, right? So that's the length of my my bits of wire. Before I solder it, I'm going to strip a little bit of the plastic off each end of each wire. So I'm taking off about, it's hard to see it there, that's about 6 millimeters, 5 or 6 millimeters off the end of each wire. For all the wires that you strip to put into the breadboard, you don't want the metal to be too long at the end, because if it is, you end up with metal exposed above the breadboard, which can create short circuits. And you also don't want it to be too short, because then it mightn't actually connect properly inside the breadboard. So about 6 millimeters. Now I strip the same amount off the two ends of the wire. So it's about 6 millimeters off each end, and I'm going to do that for the two wires that I'm using here. So one end of each wire will be connected to a motor terminal. The other end we're going to plug into the breadboard later on. Okay. Now, did I have some insulating tape there somewhere? A roll of tape.
There is a roll of tape in there.
I actually use this, right? So, roll of duct tape. Now I'm just going to use this to help me out as a sort of a pair of magic hands. This thing here is a crocodile clip. So called because it's got a little spring-loaded kind of thing like a crocodile's jaws. Is that clearly there? Mm-hmm. I'm just going to wrap that into a roll of tape just to create a little standing up clip that I can sit things into if I need them to be held secure while I'm soldering. So just tape that in like that.
Okay.
There. Okay, and it means that I'll be able to clip something in there while I'm soldering it if I need to. Okay, safety with the iron. The iron is hot, but it's not all that hot, right? It's about maybe 400 degrees, something like that, Celsius. So it wouldn't be all that much hotter than a very hot like pizza oven or something like that, right? However, there is in fact this one is at 356 degrees. I've just noticed there's a little thermometer on the side of it, which is handy. Now, what you need to know about the soldering iron though is that it doesn't radiate heat very effectively. So you can see it's kind of like a shiny silver material on the tip of the soldering iron. And actually silver shiny materials don't radiate heat very effectively. So if I put my hand quite close to it, I can't even really feel that that's hot at that distance at all, right?
Let's not test that though.
Let's not. So even though it's roasting hot, I can't actually detect the heat off it. It doesn't feel hot, right? If you compare that to something like, have you ever seen anyone walking on red hot coal? See, sometimes you'll see like people do it as a kind of a magic trick. They have like got a whole load of red hot coals laid out on the ground, and then they walk across them, and they could be walking on them for like 8 seconds, 9 seconds, 10 seconds, and then they get off the other end and they don't get burned. And the reason is that what happens with coal is when it's hot, it's very, very effective at radiating heat. So you actually look at it, it looks hot. Got like lots of infrared radiation coming out of it, and you can feel the warmth miles away from it, right? However, ironically, coal doesn't actually conduct heat very well. So if you put your hand very close to a red hot piece of coal, it's not all that much worse than putting it on the red hot piece of coal. And I'm definitely not suggesting that you do that, right? Do not try it, because even if you hold your hand near coal, you'll get burnt. It's so good at radiating heat. But the point I'm making is that basically heat comes out as radiation, not conducted. This is the exact opposite, right? This does not radiate heat well, so you can't feel by putting your hand near it that it's hot, but it conducts it incredibly well, right? So the whole design of this tool is designed to dump heat into something that it touches very, very fast. So it's actually deliberately got a thickened kind of a metal collar on the end of it there to store up heat energy that can be conducted very, very fast into something that it's in contact with. So from a health and safety point of view, what that means is that if you touch it, you get burnt straight away. Alright? So even though it's not the hottest thing on earth, it's one of the best things on earth at burning you. If you've ever, at some point, and if the side of your hands touches off the shelf or touches off the side of the oven, you get burned very fast because the oven's made of metal. It's the same kind of problem. It conducts heat very, very well. So you get a kind of an ashy white sort of a burn straight away, and it'll come up in sort of blisters afterwards. So this does that. So you definitely don't want to touch your skin with it. And most importantly of all, you do not want it going into your eye, which can happen sometimes because if you tug on the cord, it can get flipped around, and in the worst case scenario, it could hit you in the face or even in the eye. So the purpose of these glasses is whatever else this touches, it's not going to touch my eye. Alright, that's part of the reason for the glasses. Okay, so with all of those dire warnings, now on to actually getting a good solder joint. So the golden rule to this, which a lot of you may or may not be aware of, is to put solder on the two things before you bring them anywhere near each other. So I'm going to be joining a wire and a little metal terminal, but I don't want them anywhere near each other until they're both already coated in a thin coating of solder. A lot of people's instinct is to get the wire twisted onto the terminal and then drop on a big blob of solder onto it and try and entomb the joint in solder, and that won't produce a good solder joint at all, right? What we actually want to do is use the iron to heat up each of the pieces of metal on its own until the metal itself that the solder is going to go onto is hotter than the melting point of the solder, and then we're going to let a little bit of molten solder run over it, and it'll coat the material and form a very kind of good chemical bond with the metal that we're actually trying to attach. We're going to do that individually to the two pieces and then bring them together. So I have the iron here. This yoke here is the brass kind of scrubber that we can use to clean the tip of the iron, so to take off anything that's on it. And it also has a stand for the iron, so when you're not using the iron you can stand it up. This is another type that you might find in your room. So it has that kind of spiral holder for the iron. But there's also a kind of a sponge there that you have to wet, and that's another way of cleaning the tip of the iron. Okay. So when you look at the tip of the iron, it should look kind of clean. I know it's kind of hard to see it there on the camera. Also, there's a kind of a flat, shovelly surface on one side of it. You can just see it's on the kind of lower side now. But that sort of flat, shovelly surface of the tip, that's the bit that you're actually going to use to do the soldering, right? So what I'm going to do first is I'm going to wet that flat surface on the tip of the iron. So I'll clean off any dirt or anything that's on the end of it there, and then melt a tiny bit of solder on. And we call this wetting the iron. So it's probably hard to see it on the camera, but there's a very, very small drop of molten solder sitting on the tip of the iron there now. Now the purpose of that solder isn't actually to form the joint or anything. It's to make the tip wet so that when it comes into contact with the metal that you're trying to heat up, it'll form a very effective bridge for the heat to transfer from the iron into the thing that you're trying to heat up. So I'm going to put solder onto one terminal of my motor. Are you able to see that there?
Kind of.
So the way I'm going to do this is I'm going to just wet the iron and come in to the metal piece from underneath. Now you'll notice that there's a little bit of smoke coming off this. And what's happening there is that the solder, when you melt it, it releases a chemical called flux, which has been put in a sort of a thin band down the middle of the string of solder. Some of it burns off, but some of the flux will run onto the metal, and it's got a kind of a corrosive, acidic chemical makeup which will clean the piece and allow the chemical bond to form between the solder and the metal. So that tab of the motor, I'm just putting a real thin coat of solder on it. I don't know whether you can see that at all on the camera.
Not really. The yellow is just throwing the...
At the bottom of the motor, that's one of the metal tabs, and you can see it's kind of got a silver colour. So it started out as sort of a brass colour, but it's only a very, very thin coating of solder that's on it. It's almost just changed the colour without changing the shape. But the entire surface of that piece of the motor is now covered in solder. So I'm going to do the same for the other terminal. I'll clean the iron again, wet the iron, and then come in, and the iron is heating the piece from one side, and I'm bringing in fresh solder from the other side in order to actually melt some onto it and release some flux. So basically what I end up with then on the motor is I've got two terminals, which are each of which has got a very thin coating of solder on it. I'm going to do the same thing for my wires now, and to do this I'm going to use the little clip that I made before just to hold the wires. It's a good idea when you're putting solder onto a wire like this to try and orient the wire so that the tip that you're soldering is kind of pointed downwards. That way if you put on more solder than you intend to, the solder will tend to form a drop at the end and you can just cut it off later on. So hopefully this is that anyway visible? Oh yeah, it's not too bad. Okay, so same thing again, clean the iron in the brass wool, wet the iron, and then come in from one side and heat the piece with it and bring in fresh solder from the other side. And I'm just going to kind of run it down the wire like that. So what I've got now is the end of my piece of wire is coated in a very thin coating of solder. Again, you can hardly see it on the wire because the actual core of the wire is silver already. So when you put the solder onto it, it doesn't look much different. So you need to remember which end you've put that onto. Okay, so I'll leave that one there and I'm going to put solder onto the other wire. So clean the iron, wet the iron, and then come in with the iron from one side to heat the piece and fresh solder from the other side, and that should clean it off. So I've got two pieces of wire now, each with solder on them, and I've got two terminals on the motor, and all that remains is for me to put them together. Now I am going to need a little bit of solder to do this, but the solder isn't really to form the joint so much as just to facilitate the heat transfer from the iron into the joint to get the other bits molten hot so that they can actually bond into a single one. Now one thing that's useful to do here, I'm going to run out of hands when I'm doing this because I'm going to be using one hand to hold the wire and the other hand to hold the iron. So what I'm doing with the solder the piece of solder that I have on the table is I'm kind of coiling it up there like almost like a snake, if you can imagine, like a python or a cobra or something like that, coiled up with its head in the air. This means that I'll be able to access this little piece with the iron. When I want to wet the iron, I can just touch it off that because it's up off the surface of the table. Now I should probably say a word as well about how I'm holding the iron. I'm right-handed, so I'm holding the iron in my right hand, and I'm holding it kind of like I would hold a pen. So like with my fingertips. Anytime when you're soldering, one of the big things in order to manage the process in a way that'll produce a good joint is to just get the ergonomics right. What I mean by that is you want to make sure you're working at a surface where you can rest your hands stably on the table, where you can hold the things that you need to hold without them shaking around. Trying to solder with your hands in the air like this is very, very difficult because the movement needs to be controlled very precisely. So you want to do it more like as if you're writing. So you're holding the iron like a pen. And I'm going to be using the other hand, as I say, to hold this wire. So I've got my solder up in the air here. I've got my wire, which is already coated in solder, and I'm going to connect it onto one of the terminals of the motor, which is also covered in solder. So clean the iron, wet the iron, and then I'm holding the wire in the same place as the thing I want to connect it to. There's no twisting them together or anything like that. I just want them to be lying against one another. And then come in with the iron to melt the solder. And you only have to melt them and hold them together for a second. Once you release the iron, the joint will be formed very quickly, as in it'll set. And you get a very good, robust connection on the wire then. Now, if I tug that hard, the solder joint is actually strong enough that it probably wouldn't break. It's more likely that the terminal on the motor, which is quite flimsy, would break. So that's actually a pretty solid joint there. And you can see it only took a second. Once the two things have solder on them, they'll go together without any difficulty at all, right? So do the same thing for the other one. Again, both of these pieces already have solder on them. So wet the iron and come in with the wire here. I'm going to heat the terminal from one side, and as soon as you take the iron away, it'll set within 1 or 2 seconds, just as the temperature drops back below the melting point. So there's my two wires on there. They're both very robust. If you have too much poking off the end here, you can just clip it off later on with a snips. Now you might be wondering why I've put on the wires this way. Most people's instinct would be to have the wires trailing off in the other direction, away from the motor, down this way, whereas I seem to have laid them up parallel to the body of the motor, right? Now there's a good reason why I've done that, and if I can find my insulating tape, I'll show you why. Add some physical strength and robustness to those wires. At the moment, they're attached to very fragile terminals on the end of the motor here, and there's a danger that in time those terminals will just crack and break off just from being tugged around. So the way that we often make these particular type of motors more robust is just by wrapping some insulating tape around the collar of the motor. So I'm just putting a nice tight band of that around there, and it means that when you pull on the wires, the strain has just been taken by the cables, or sorry, the strain that you're putting on the cables has been taken by the tape, and it doesn't get felt by the terminals in the motor up here. That will make the motor much, much more likely to survive what you're going to be putting it through over the next few weeks. So this is something that you could probably try and get done today for both of your motors, right? Get the wires put on them like this.